Hi, good morning. I guess I'm not there. Sorry. I know I told some of you guys I'd be back today. Thought I would. Uh, but in all fairness to the judicial system, I guess we're trying to be as fair as we can um, and get to the right verdict. So bear with me. I'm hoping to come back tomorrow. So meanwhile, I'd like to do a mini review of the things that you've been working on. If I do come back tomorrow, I will give you a small quiz, a very, very small quiz. But nevertheless, let's get to this. So, on your table of contents, you can write mini review. You can press pause at any second. You should be all used to this by now. Once again, I apologize for the delay. So, mini review, and let's just take topics that from the beginning, okay? So, this is a preview, and you do have a test. Reminder, your marking period ends soon. You got maybe 2 more weeks. So you have a you have a test. You definitely have a test coming up. You might even be at the end of the week, depending if I come back tomorrow, or it might be Monday. So let's get to this. So I want you to copy whatever's on the screen. I do want you to copy. I'm not going to take too much time. I'm going to do a little review, and then you're going to get a little sheet, another handout. Ooh, includes coloring, but it also includes percent, decimals, and fractions. So besides those, let's try to refresh a few things that you learned a while ago. All right, so first thing I want you to do is copy this, and it's talking about integers. So it says use the appropriate integer to describe each situation. Okay, remember what an integer is. An integer is all the positive whole numbers, the number 0, and all the negative whole numbers. Okay, those are integers. So the family of integers includes -3, -20, -40, -1,000,000, 0, and then on the other side, all the positive numbers, 1, 2, 3, 4, 5, all the positive whole numbers, I should say. Okay, so press pause when you come back. Let's see what you wrote down for each. All right, so went down 4 floors. If you're going down 4 floors, it usually means if you're going to use an integer, you would probably write, and let me pick a color here, -4. Okay, going down usually has a connotation, a negative connotation. Gained 20 pounds. So if you want to describe that situation using integers, you would write +20. A moving +20. Okay, let me erase this. Don't you just love it when it just moves around? Alright, so this is +20. And then finally, it is 5 below 0. So if it's 5 below 0, hopefully you wrote -5. Okay, so those are examples again of a few situations where we do use integers. Okay, next page. Define absolute value. Okay, so and then at the bottom you have what two numbers have an absolute value of 7. Take a minute, answer that, and then press play again. So hopefully if you didn't remember, of course you're allowed to use your notebooks. Go back to your notes. Absolute value is, in its simplest terms, it is the distance. It is the distance a number is away from 0. Away from 0. So how far or how many steps do you have to take to go to 0? So if you are at 5, and you know what, let me lower this for a second. I'll draw a number line. So let's take that and let's draw a number line right here. Okay. So let's take an example. And if this is 0, let's pretend you're standing right here at 5. And you had to walk back to 0. How many steps would you need to take? You need to take 1, 2, 3, 4, 5. So the absolute value, and remember, absolute value is shown by using these two vertical bars around 5. So this right here says find the absolute value of 5. And finding the absolute value of 5 means how many steps do you have to take to go back to 0. So you would have to take 5 steps. 5 steps. So same thing on the other side. Let's say you're standing here and that's -8. And again, let's write that. So absolute value of -8 would be written in that way. And the question would be, how far are you away from 0? So to go back to 0, you would take 1, 2, 3, 4, 5, 6, 7, 8 steps. Remember, distance cannot be negative, so that's why your answer is always positive. Okay? So -8 is 8 steps away from 0. So the absolute value of -8 is 8. Okay? So bottom question, what two numbers have an absolute value of 7? So there are two numbers out there that have an absolute value of 7. Well, I'm going to use a number line here. If this is 0, I'm moving 0 again. If that's 0, what number has is 7 spaces away from 0? Well, on this side, on the right side, on the positive side, let me make this negative. On the positive side, there's a number here. That number is 7. This number right here is 1, 2, 3, 4, 5, 6, 7 spaces away from 7. So that's one number. And guess what? There is another number. On the other side, on the negative side, this number is also 1, 2, 3, 4, 5, 6, 7 spaces away from 0. So there are two numbers that have an absolute value of 7. So I can write absolute value of -7 is 7 because you need to take 7 spaces, 7 steps. And the absolute value of 7 is also 7. So these two numbers, -7 and 7, are both 7 spaces away from 0. Okay? It's a little refresher for you guys. Next page. Find the absolute value. Okay, this should take literally 10 seconds for you to do. Okay? So, press pause. Alright, so find the absolute value of -8. So -8, how far is it from 0? It's 8 steps away from 0. Absolute value of 0. 0 is 0 steps away from 0. You don't have to go anywhere. -2. -2 would have to take 2 steps to go back to 0. So the absolute value of -2 is 2. And the absolute value of 40. 40, it's 40 steps away from 0. Okay? It's very simple. User equal or less or, user greater, less or equal sign. Okay? So you have 3/7 and then 4/9. So you want to use one of the three symbols here. Well, hopefully you remember. Alright, actually I didn't tell you to press pause, so this is a good time to press pause. Okay, press pause before I continue my explanation. Press pause, figure it out, come back. Okay, what's my problem here with my two fractions? Well, the main problem is that they have different denominators. And they have different denominators is very hard for me to compare. 3/7 or 4/9. I don't know which one is greater or smaller. So I would suggest you make a change. Change these two fractions so that they have the same denominator. Well, in order to change them, you have to think of a number that 7 and 9 both go into. Well, 7 and 9, the one number they both go into is 63. 7 goes into 63, and guess what? 9 also goes into 63. Now, so you've changed the bottom here to 63. So I did 7 times 9. That gave me the bottom 63. Remember, in a fraction, if you change the bottom, you must change the top. So I multiply it by 9 as well on the top. So that gives me 27 over 73. So 3 over 7 and 27 over 63 is the same thing. Okay, the 9 here became a 63. How did I do that? I changed that by multiplying it by 7. 9 times 7 is 63, so I have to multiply the top by 7, and that gives me 28. Now, it's much easier to determine which one is greater. 27 over 63 or 28 over 63. Which one is greater? Well, obviously, 28 over 63. Okay, so to use one of the symbols here, I'm going to say that 27 over 63 is smaller or less than 28 over 63. Okay? Here, again, same thing. They have different denominators. These are negatives, though, so be careful. Let's make sure we have our negative sign. And we're going to pick a number that 8 and 12 goes into. Well, okay, this is finding the LCM. Okay, remember, I'm going to do it on top, just in case you guys forget. 8 and 12. Find the LCM is least common multiple. So multiples of 8. 8, 16, 24, 36, 48, 12. 12, 24, 36, 48. And I have no idea what I did on the top because that's all wrong. So forgive me here. I was thinking of something else. Well, 24 was correct. And that's correct. After 34, stripping 32, 40, 48. Now they're okay. So LCM, least common multiple, the smallest number that they share is 24. So I can change both denominators to 24. That becomes a 24. That also becomes a 24. So 8, how does it become a 24? I multiply by 3. I multiply the bottom by 3. I multiply the top by 3. That gives me 15. 12 over 12 becomes a 24 by multiplying by 2. So the top by 2. So that gives me negative 14. So now these are negatives, so you have to think backwards. In negative, the bigger the number, the smaller it is. So again, negative 15 over 24, because it's bigger, but since it's negative, it means that it is smaller. Okay? Let's do a couple more, just in case. So do these two. Again, press pause. Okay? Alright, so this one. Again, 4 over 10 and 8 over 17. I would change the bottoms. Okay, 10 and 17. You would have to find the LCM. So if you want, somewhere in your notebook, do this. And let's start listing their multiples. So 10, 20, 30, blah, 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 17, 34, 51, and goes on and goes on. But if you actually did this, you would find that they would meet up way, way down the line at a number called 170. So 10 times what's 170? 10 times 17. So I multiply the top by 17 as well, which gives me 68. 17 was multiplied by 10 to get 170. So I multiply the top by 10, and I get 80. So now you can easily tell which one is bigger or smaller. So 68 over 170 is smaller than 80 over 170, which means on top is the same thing. Okay? 9 and 4. I would change them. The LCM between 9 and 4 is 36. Okay? And here would be 9 times 4. Gives you 36. So top is 9 times 4, which is negative. I forgot the negative. 8. 4 times 9, excuse me, 36. And 1 times 9, negative. And again, in this case, 8 over 36, okay, remember, in negative numbers, okay, the bigger the number, the smaller you are. It's the opposite. So negative 8 over 36 in this case is greater than negative 9 over 36. Okay? Order these decimals from least to greatest, so take a couple of minutes to do this. Okay? Press pause, come back. Alright, so if that was me, what I would have done is put them under each other. 4.404. And remember, when we're putting decimals under each other, make sure each decimal of each number is lined up like that. And I would write 404. Next one will be 4.4. And remember, decimal under decimal, so they are lined up correctly. Then 4.444. And finally, 4.04. 04. Now, notice that not all of them share the same quantity of digits. So what I'm going to do is put a placeholder. I'm going to add a 0 here. I'm going to add a 0 and 0 here. Okay, so remember a little trick I told you in class, and I don't know if it's a wise trick, but you can pretend for a second that there is no decimal. So what I'm going to do is I'm going to come here and erase these decimals. So if you were to erase this, okay, just for now, because you have to put them back, which number would be the greatest? This would read 4,404. This would be 4,040. This would be 4,400, 4,044, and 4,004. So by looking at this, your smallest number is this guy right here. And I'm going to put the decimal back there. Your second smallest number would be 4,000 and this guy right here, 40. And I'm going to add the decimal. My third number would be this one, the 400. 4.400. My fourth number would be this one, 4.404. And finally, obviously, the leftover would be my greatest number, which is 4.444. Okay. Ooh, now these are negatives. You know, I'm going to use a number line. Press pause, put them in order from least to greatest, and you know what? Let me change the question. Hopefully you're still listening to me. Order these decimals from least. Instead of doing that, let me cross that. You know what? Let me just. Let's put these numbers on a number line. Okay. So let me change. So you can start. Put the decimals on a number line. Okay. So press pause, come back when you're done. Alright, so I am going to put 0 way over here because I don't need this side. My positives, they're not necessary. Okay, here I'm going to need -1. I am going to need -2. And I'm going to need -3. Okay, so how can I do this? Well, let's start with -2.8. Okay, let's start with this number right here. So if this is 0, and I'm going this way, and I'm increasing, the number is increasing. 0, -1, -1.1, 1.2, -1.3, blah, 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 -1.9, somewhere around here, -2, -2, -2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8 should be about here. You know what? I'm going to use the letter A. Next one, negative 2.5. Well, negative 2.5 has to be between negative 3 and negative 2, so somewhere right here in the middle. Negative 1.9, and here's where I know there's going to be a confusion. Some of you are going to put it on this side, some are going to put it on this side, to the right of the 2 or to the left of the 2. Well, start at 0, guys, and start walking. Okay, if you were going to walk, that's 0, and your numbers are increasing. Negative 1, negative 1.1, 0.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 would fall right about here. That's a C. Negative 0.55. Okay, forget the negative. So you know the only thing you should worry about is going towards the left. So if that's 0, 0.1, 0.2, 0.3, 0.55. 0.5 is in the middle. 0.55 should be just a little bit more than the middle, and we'll call that D. And finally, we got negative 3.8. Well, that's negative 1, that's negative 2, negative 3. This is negative 3.5. Negative 3.8 should be about here. We'll call that E. Okay, so there is no trick. I mean, just start walking towards your left and start increasing the number. Okay, and just remember that it's the only thing is that it's negative. Okay, a little bit of percents, just in case you forgot. Tony got 17 out of 25 on our test. What percentage is that equivalent to? Remember we talked about that percent proportion? And we'll always start like this. And the rest, you start filling it up. On top of the 100 will always be your percent, if given. In this case, it's not given, but it's what we want to find out. So I'll put a question mark, because that's what we want. Second part of our, excuse me, second part says 17 out of 25. Remember, top is always part, bottom is always total. Well, there were a total of 25 questions, so 25 goes at the bottom. And part of it was 17, which is the one that she got correct. So, look for relationships, and we can. 25 is times 4, and therefore 17 will be times 4. And if you multiply 17 times 4, you get 68, and that's your answer. So you should write Tony got 68%. Okay. Now, I forgot to press pause. Hopefully you did. What is 20% of 25? Okay, press pause. Take a couple of minutes. So, let's look at the question. We have 20%, and percent will always go on top of the 100, so I can put 20 right there. Okay, remember, on the other side, it's part over total. So what is 20% of 25? So imagine if you had $25 and you used 20%. Okay, so what is 20% of 25? 25 is what you have as a total, and you used 20%, which is a part. That's where you put your question mark. Look at your relationships. 20 to 25 is divided by 4. And 20 to go to our mystery number is also going to be divided by 4. And 20 divided by 4 is 5. So what's 20% of 25? 20% of 25 is 5. So if you had $25 and you spent 20%, that means you spent $5. Okay? Larry used 15% of his $40. How much did he use? Okay, so copy, and press pause, solve, come back. Okay, so 15% is given to us, so percent goes on top. And we have to figure out if 40 is the part or the total amount of money that he had. So he used 15% of his 40. So obviously 40 becomes the total. And part is what we want to find out. So how much did he use? What does it mean when he said he used 15% of his money? Now, you're going to notice something here, okay, that there is no relationship here. Okay, there is no relationship between 40 and 100 or 140. Okay, so I hope you remember that we can make changes. And let me just erase this arrow here. But you can't make changes to the 40. Okay, we can't make changes on this side. We can't make changes to this guy. Why? Because it's not a complete fraction. Okay, the numerator is missing. But in this, on this side here, 15 over 100, we can change the 15 to 100. So instead of using 15 to 100, so let me write this side. We're going to leave this question mark over 40 alone, and we're going to change the 100 to something else. So 15 to 100, dividing it by 2 is not going to help us, because if I divide 15 by 2, it's going to give 7.5. Okay, so if I divide this by 2 and the bottom by 2, you're going to get 7.5 over 50. And that really doesn't help us as well, because there's no relationship between 40 and 50. So instead of going down, let's go up. Let's multiply that by 2 and the bottom by 2. So instead of saying 15 over 100, let's write 30 over 200. Ooh, that's going to help. So here's 30, here's 200, and there is a relationship between 200 and the number 40. So we're going this way. From 200 to 40, okay, it's divided by 5. 200 divided by 5 is 40. So guess what? We can apply that same on the top. And 30 is going to be divided by 5, giving you 6. So Larry used $6. Okay? So remember, change, if there is no relationship, change the ratio. Okay? But you got to change the one that is complete with a numerator and denominator. In this case, we had to change 15 over 100, not question mark over 40. Okay? You have to change this one right here on this side. Michelle answered 16 out of 40 questions correctly. What percentage did she answer correctly? Okay, so not a big deal. Press pause again. Try to do it on your own. Okay. Alright, so let's fill this out. It always starts like this, and we want percentage. So what percentage she has? So the percentages are mystery numbers, so I'll put a question mark over here. And the other side, 16 was the part that she got correct, and 40 was the total number of questions on the test. So again here, in this case, you'll notice that there is no direct relationship, a whole number relationship between 40 and 100. Nothing multiplied by 40, whole number wise, will give you 100. Okay, so again, you need to decide, you need to change things around. Well, we're not going to change the question mark over 100 because that's not a complete fraction. One of the numbers is missing. I'm going to leave that alone. But we can change 16 over 40. Okay? So, let's see if dividing it by 2 helps. 16 over 40, divide top and bottom by 2, gives you 8 over 20. And that, automatically, you should realize that it does help. So instead of saying 16 over 40, we're going to write 8 over 20. And 20 to 100, there's a relationship, a nice whole number relationship. It's times 5. So I'm going to multiply top times 5, and I get 40. So Michelle got 40% correct. Not a great test score, but that's what you got. Okay. There's a couple more. So change to an improper fraction or to a mixed number. This should be very, very easy, so I don't expect you guys to take that long, a minute. Copy, pause, pause, copy. Okay. All right, so to change to from a mixed to an improper, which is this case right here, a mixed number, it's this way, and then this way. And this is times, and this is plus. You can always write that to help you. So 3 times 9 is 27, plus 8 is 35. Denominator stays the same. Okay. This is a improper fraction, so 12 goes into 45. You can do a division. You can do 45 divided by 12. Remember, the numerator always the number that goes inside. 12 goes into 45 3 times, 36. If you subtract, you get 9 left over. So that's it. So our 3 here on top becomes our whole number. Our remainder goes on top, 9. And our fraction at the bottom, our denominator is 12. We're not done because we can simplify 9 over 12. The 3 stays the same. And 9 over 12 becomes 3 over 4. Divide top and bottom by 3. Excuse me. Okay. Change the decimal to a percent. Okay, hoping we did this the other day. To change the decimal to percent, the easiest way, okay, and I think I showed you, is to move the decimal to the right. So we're going to take that little dot and move it 1, 2. Uh-oh, battery's running. So, let me... There. So we're moving the decimal that was between the 0 and the 3. We're going to move it 1 spot, 2 spot, and it's going to be right here. So let's clean that up. So our new number is 3, 4 with a decimal at the end, and we add the percent sign. And guess what? We don't need this decimal. Okay, so cleaned up, it looks like 34%. 0.06. So again, we're going to move this decimal 2 spaces to the right. We're going to go 1, and go 2. So the decimal is moved all the way from that side to the right. Now we add the percent sign. And to make it even prettier, we can eliminate that decimal and make it 6%. Last one, 0.5. You're going to move, again, the rules don't change. You move it 1, you move it twice, and here's my new decimal. So to clean it up, it becomes 5. The empty space on top, we can't leave it empty. We add a 0, the decimal, and our percent sign. And to make it even better looking, we just write 50 with a percent sign without the decimal. Okay. Change the percent to a fraction in simplest form. Again, pause, copy. Alright, so to change it to a fraction, you know a percent is a ratio compared, number compared to 100. So anytime we're talking about percent is something compared to 100. In this case, 84% is 84 over 100. Okay, the only next thing you had to do was to simplify, and I believe we can divide this by, I don't know, let's try 4. Divide by 4, divide by 4. Divide by 4 on top, I get 21, and at the bottom, I get 25. Ooh, that was right. 140. Again, it's the same thing. It's a number compared to 100, so it's 140 over 100. Let's simplify this. I'll divide top and bottom by 10. And I'm going to get 14 over 10, which I can still simplify, divide by 2. And I get 7 over 5, which I can finally change to a mixed number. 5 goes into 7 one time, 2 left over, and 5 as my denominator. Final answer, 1 2/5. Okay? change the fraction to a percent. Ooh, how are we going to do this? Okay, press pause, look over your notes. So, change the fraction to percent. Okay, I'm going to keep this consistent. So to change the fraction to percent, I would change this fraction to a decimal first. How do I change 4 over 5 to a decimal? Well, 4 over 5 is a decimal. In order to change a fraction to a decimal, you got to divide. So 4 goes inside, 5 goes outside, and I divide. 5 goes into 4, no. Add a 0, add a decimal, add a 0 here on the side. 5 goes into 40, 8 times. Perfect. So 4 over 5 as a decimal, so let me write this again. 4 over 5 as a decimal is 0.8, which you now know how to change to a percent. So you take that from a decimal, you move that 1, 2. Here's my new decimal, so to clean that up, okay, I'm going to write 8, 0%. Or even better yet, 80 without the decimal, 80%. So 4 over 5 is the same thing as 0.8, which is the same thing as 80%. Okay, 8 over 15, same thing. So let's see, 8. Nope, that's not an 8. Here's the 8. No, it's not an 8 either. Try again. Okay, 8. I'm going to divide it by 15. 15 does not go into 8, so I can add a 0 on top. This. And 15 goes into 8 5 times, which is 75. Okay, subtract. 5 left over. I'm going to bring another 0 down to see if that helps me. 15 goes into 50 3 times, which is 45. And 5 left over. If I bring another 0 down just to keep on trying, notice that it's a pattern, so it's going to be another 3. So the answer to this question, okay, is 0.533. So the 3 here is going to repeat and repeat and repeat. So the answer is 8 over 15, and depending on the instructions of the question, it'll tell you to round. So one way of writing this would have been this, okay, because this 3 is a repeating number, so you put a bar notation on top of the 3, or if it just says round to the nearest hundredth, you could have left it like this, and nearest hundredth is this one. Okay, you stop at the hundredth. So using 0.53, so 8 over 15 is the same thing as 0.53, and if you want to move or change that to a decimal, you move the decimal 1, 2 spaces to the right, and it becomes 53 with a dot and a decimal, or just 53%. Okay? And we have one more. Yes, change the percent to a decimal. Okay. Change the percent to decimal is backwards. Step 1, eliminate the percent sign. Step 2, press pause, which I forgot to tell you. Okay, so take a couple of minutes, do it, come back. Alright, so 45%, it's a percent. You want to change it to a decimal. So first step is removing the percent sign. So here's my number, 45. There is no decimal, none that I can see. So anytime you have that situation, you put the decimal way at the end on the right side. There's where your decimal is. Invisible, but yet it's still there. So 45%, first thing I did was eliminate the percent sign. Second step I did was add a decimal because they didn't have one. Now I have to move it to the left. So 1, 2, move it to the left 2 spots. So my final answer is 0.45, and we're going to add a 0 in the front to make it pretty. So 45% as a decimal is 0.45. Okay. Here, same thing, 0.6. Get rid of the percent sign. Let's write it again. And we're going to move the decimal to the left 2 spaces. We're going to go 1. We're going to go 2. That's my new decimal spot. So it's point. And that empty space that's here cannot remain empty, so you add a 0 as a placeholder. Copy the rest. So, and that's my final answer. Now I'm adding a 0 here in the front. So 0.6 as a decimal is 0.006. Okay? And that's that. It should be a very, very brief review. So what I'd like you to do for the remaining of the period, you're going to get a handout. It's called Quilts with Fractions, Decimals, and Percents. Okay? You're going to see it. You're going to see a grid that has 100 boxes. Okay, and I want you to use the following colors: red, orange, yellow, green, and blue, and color it. Okay, each square with a different color, and it's called a quilt because I'm eventually going to cut them all up and then put them together. You'll see what I mean. It's going to be in like big conglomerate of colors. But anyways, so you have a grid with 100 boxes. Use the colors that I mentioned: red, orange, yellow, green, and blue. Get a marker, get a crayon from the back. You guys know where it is. And color them. And then on the right side, you're going to later fill in how many boxes you colored red, how many boxes you colored orange, yellow, green, and blue. And using those numbers, you're going to fill the box at the bottom where you're going to change. You're going to write it as a fraction, a decimal, and then as a percent, depending on how many you colored from each color. So for example, red, if you colored 20 boxes red, as a fraction it would be 20 over 100. As a decimal it would be 0.2, and as a percent it would be 20%, and so forth and so forth. So if you don't finish that, you'll finish that for homework, and hopefully when I'm back tomorrow I'll collect it. Okay? Alright, that's it, and this video is also on the class website. Okay? So thank you guys. Bye.